Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 2 from lesson 5-5 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to learn how to multiply functions. Now, if you've been working with Savvas for a little while, you have probably already learned how to multiply functions. You know, it's a type of distributive property. But what we're doing here is we're actually learning kind of a new notation that you didn't see when we learned this with polynomials. So let's take a look at this problem. So there's this company that creates cell phones who have created this formula. They say that to find the revenue of a sale, it's equal to the price of the cell phone times the demand. All right, so the price they're referring to with just an x, so that's the price function. Another way to say it is that is P of x, and the demand is D of x. So what it's asking, it says, what is the company's expected revenue from the cell phones in terms of the price, x? So what we're going to do is we're going to go ahead and find P times D of x. And that's the notation that you may not be familiar with. So all that this is saying is to take the price function and multiply it times the demand function. So remember, our price function is x, and I'm multiplying it times the demand function, which is 5,000 minus 10x. And the only thing that I need to do here is distribute. So P times D of x is 5,000x minus 10x squared, because I used the distributive property there. Now, kind of a little bit of a heads up here. Some people like to be really cutesy with how they write, and instead of putting a dot, they might put a circle like that. Oh, look at how nice that looks. Do not do this. Okay, that circle is specifically used for the compositional functions, which is saying to take d of x and plug it into p of x. Okay, so it's very important that you're using a dot and not a circle, because otherwise your notation's not going to be looking quite right. So let's go ahead and let's take a look at this one. So it says, suppose that the demand is predicted by this function, and that the price is given by this function. And again, they want us to find the revenue. So this is just another multiplication problem. So remember, the revenue is the price times the demand in terms of x. Now eventually they might give you an actual number for x, like they might give you an actual cost of the cell phone. But in this case, we're not. We're doing it for any cell phone price that we choose. So I'm taking the price function, which is x plus 16, and I'm multiplying it to the demand function, which is negative 0.25x squared plus 1,000. Now, you can multiply this in multiple ways. You could use the distributive property, which is what I'm going to do, or you could use the box method, which I've shown on previous videos. Looks like that. It doesn't really matter. Multiplication is multiplication, let's be honest here. So I'm going to take the x and times it to each of these terms here. So x times negative 0.25x squared is negative 0.25x to the third. And x times 1,000 is 1,000x. And then I'm going to take this 16 and I'm going to do that same process. I'm going to multiply it times these things. So 16 times negative 0.25x squared is negative 4x squared. And 16 times 1,000 is 16,000. Now, traditionally, we usually want to write our answers in that standard form. So I want my exponents to count down. So all that I'm doing is I'm rearranging this so that my exponents count down in my polynomial, and it's pretty. All right. You could leave it in this form as well. So there we have it. That is how they generate a revenue function. Until next time.